Being able to navigate file directories is very important. Our goal here is to read every book contained in the various subdirectories of our book folder. In order for us to read the directories, we first need to import the OS module. I also want to be keeping track of my book directory. I'm going to call that book dir, and it's the directory we've seen before, books. And let's just run that as well. Let's see how the function works. os.listdir book directory. In this case, Python is telling us that the present directory contains 4 items: English, French, German, and Portuguese. These are subdirectories for books in these 4 different languages. We want to read all of the directories that are contained within the book directory. The first level is going to be the language directories. We first want to generate a list of the directories that are contained within our books directory, which we can do by saying os.listdir, and we'll do this in our book directory. This returns us to a list which we can loop over. Since these directories will correspond to different languages, I'm going to call the loop variable language. So we'll say for language in os.listdir book directory. The second layer is going to be the author directory. For author in os. In this case, we need the book directory, but we need to add the new directory that we're currently in, which is the language. We can do this by concatenating strings. We take our book directory, we add the slash, and to that we concatenate the language. This is our second loop. Finally, we want to be looping over all of the titles that are contained within this directory. So we'll go with title, and in this case we need the same as we had before, book directory plus language, but we need one more component here, first slash, then plus author. Just to be clear, our first for loop is looping over languages. The second for loop is looping over authors, and the third, the innermost for loop, is looping over different titles, different books. I'm going to define my input file here, which is the directory that I had before. But to this we need to add one more thing. First our slash, then our title. This is the path, the full path of the book, starting from my present working directory. It's useful to print this out to make sure that my function is working correctly. So I'll just print that out using the print function. On the next line, I want to read in the book. So we just say read book. I can now use the short name for my input file. At this point, 2 more things remain to be done. First, we need to count the number of words in our text, and then we need to compute our word statistics. Let's first count the words. The input is text, and we can actually take this input and feed it right into our word stats function. So what's happening here is the following. We're first taking our text, that gets fed into our count words function. That returns to an object that then gets pushed into the word stats function, which returns us an object. We'll then need to capture the object that's returned, which is a tuple. So we're unpacking a tuple, num unique, and counts, and that should do it. Let's try running our function. We first have our import and the definition of the book directory, and then we have our code here. You can see what's happening here. Python is first looping over all languages, then for each language it's looping over all authors, and for each author it's looping over all of the titles. The benefit of having a print function in your code is that you can follow Python as it's reading through your 102 books. Pandas is a library that provides additional data structures and data analysis functionalities for Python. It's especially useful for manipulating numerical tables and time series data. Pandas gets its name from the term panel data used to refer to multidimensional structured datasets. Let's create a simple table using pandas. We'll first import pandas as PD, which is the convention. We then want to create a table. The most common data structure in pandas is what's called a data frame. This is very similar to the data frame structure you might have seen before in R. In this case, we'll simply demonstrate how to create a table using the pandas data frame function. I'm going to call my table simply table. We need the data frame command. And inside we need to specify the columns of our table. Let's have a table that has only 2 columns. The first one being name and the second one being age. Now we can add new entries to our table based on the location of these entries. Let's see how that works. We do this by first typing table, and we can specify the location within the table where we would like the following entry to go. I'm going to start at location 1, and you can think of that as the row 1 of the table. The first entry is a name, so it has to be a string. Let's say James. The second might be age, let's say 22. I can add a second entry, a second row to my table. I need to modify the location. Let's change the name. Let's have Jess. Let's say Jess is 32. And now we have 2 entries in my table. I can inspect my data object by typing its name, which in this case is table. To get the columns of my table, I can type table.columns. In this case, I had only 2 columns, name and age. We can now use pandas data frame to keep track of our book statistics. Let's see how that works. Let's go back to our previous code. I first need to do the import statement here so I can use pandas. And the next step is to create an empty table. I'm going to call that table stats. It's a data frame. And I want to define the names of the columns. And in this case, we'll define a few columns. I'll call them language, author, title, length, and I'm missing a quote there, and unique. And we'll put that in quotes as well. You can capitalize these terms to your liking. In this case, I'm just doing everything lowercase. This line will create an empty data frame, an empty table that has these 5 columns. To add data to our table, we also need to keep track of the row of the table. To do this, we'll define a variable called title num, and we're going to start that with 1. To store the data in our table, we need to add a line at the end of our code. We use the same syntax as before. We insert the new line, new row, and a specific location. In this case, we'll use title num. And before we forget, we have to make sure to increase that counter once we're done. And we insert to this specific location some of the elements that we care about. Language as our first column, author our second, title our third. Then we need to add the length of the book, meaning the number of words in that book. We've seen how to use this before. We're just summing over the counts that we obtained before. And finally, we'll add num unique here. And with that, we should be done. We can then run our code. And we can see that it seems to run. Let's now look at our table, which is called stats. In this case, we can see that the data frame has 102 rows and 5 columns. If you have a large table, it will probably not fit on the screen in one go. That's why it's helpful to be able to look at the top 5 or bottom 5 rows of your table. Let's look at our stats table. Head gives us the top 5 lines, and tail gives us the bottom 5 lines. In this case, it looks like our table is correctly populated. Looking at the table, I would like to make 2 small modifications. First, I would like to make sure that the authors always appear capitalized in the table. Second, I would like to get rid of the .txt file extension in the title of the books. Let's modify our code accordingly. Author name is the second column in our table. To capitalize this, we can just say capitalize. To modify the title, we replace .txt with an empty string. Now the other names will appear capitalized and the titles will appear without the .txt. Let's fix that comma into a period. Let's try running this again. Python has just read over 100 books for us. Let's look at the head, and let's look at the tail of the table. So we got rid of the .txt file extensions, and the authors now appear capitalized.